Welcome to Rex. In this video, we'll be learning about how to model data in Rex using a decision tree. A decision tree is a modeling approach that predicts or classifies data by learning simple decision rules inferred from prior data. This non-parametric supervised learning method is used for both classification and regression problems. It also sequentially applies decision rules, resulting in a tree-like display. Let's first take a look at our data. The following data was obtained for 81 children who underwent chiropractic surgery. The patient's age and month, the number of vertebrae included in the surgical procedure, the starting point for the surgery indicated in vertebrae number, and finally, the presence or absence of kyphosis post-surgery. Let's say we want to predict the occurrence of kyphosis post-surgery. Before we set up our model, let's first click Seed. Our model will perform the random division of data. In order to get the same results, we must set the same seed number. For our example today, let's set the seed number as 345. Now we can start to build our model. In order to do so, we'll go to Advanced, Machine Learning, Supervised, and Decision Tree. We'll first be using this Variable tab to define the dependent variables and any explanatory variables. As we can see, the headings in the first row of the Excel datasheet are displayed under All Variables. We can use the arrow buttons to add or remove variables from each option. Let's first select kyphosis as the dependent variable. Next, we will set age, number of vertebrae, and surgery starting point as the continuous explanatory variables. Next, we go to the Analysis tab. We can use this tab to set the analysis method and to decide whether or not to apply pruning to the decision tree model. We will select classification as the method. This classification algorithm will be used to predict the class in which the data belongs to. Next, we go to the Validation tab. In this tab, we'll decide how to divide the data into training and test data. We can also choose whether or not to partition the data or to use cross-validation to avoid overestimating. We will select Partition Data to validate the model once by splitting the data into training and test sets. Next, we will select Random Split to randomly split the data into a specified ratio of training and test sets. Today we will use the default option of using 70% of the data for the training set. Finally, let's go to the Output tab. In this tab, we can customize the decision tree and select the statistics to save in an Excel sheet. Today we will select Include Bar Plot to output a decision tree with the bar plot in each node. Now that we are done setting up our analysis, we can click OK. Once the analysis is complete, a window pops up with the results. Let's take a look at our results. Under Results of Decision Tree Analysis, we are able to see our decision tree and corresponding bar plots. Here, our decision tree indicates that the boundary between vertebrae number 12 and 13, as well as the age of 86 months, are important dividing points, also known as decision nodes, for predicting the presence or absence of kyphosis post-surgery. For example, using this decision tree, we can predict whether kyphosis will occur for patients whose surgery started on a vertebrae number less than 12 and who are older than 86 months. Based on these results, our algorithm would most likely predict that kyphosis will occur for this patient. Given that partition data was selected for validating the tree model, our results were obtained using only the training dataset. In order to measure the performance of our model, we can conduct further comparisons with confusion matrices and statistics of the training and test datasets. Here, we can see the confusion matrix for our training and test datasets. Each row in this confusion matrix represents the predicted class, while each column represents the actual true class. From these matrices, Rex calculates the accuracy measures for each dataset. For example, here we can see that the training dataset had an accuracy score of around 86%, and the test dataset had an accuracy score of around 79%. Overall, as we have seen in this video, decision trees are versatile machine learning algorithms that can perform both classification and regression tasks. Thank you for watching today's video in Statistical Analysis in Rex Pro. Don't forget to like and subscribe to RexSoft's YouTube channel for more informational videos on statistics, data, and how to use Rex.